Okay, now let's review a few things about continuity. So remember that continuity means that a function is continuous at the point x equal to a. If limit as x goes to a of f of x happens to be f of a. So that means that if I look near a and I think of the graph of my function as a wire, the wire is intact at the location where x is equal to a. Let's look at some examples of how to answer questions on continuity. So example 1. Suppose we have this function f of x equal to x squared if x is less than 1, and it's equal to root of x if x is bigger than or equal to 1. Where is this function continuous? Well, you can see that the top piece is continuous by the limit laws, and the bottom piece is continuous by the limit laws. So the only place where you might have a discontinuity is where you jump from one continuous formula to the next, when you jump from one wire to another. So let's see what happens at 1. So I will need to consider limit as x goes to 1 minus of f of x. Now if I approach from the left of 1, I am approaching along the formula x squared. So I have here limit x goes to 1 minus of x squared, which is clearly equal to 1. Now limit as x approaches 1 from the positive direction of f of x, that would be limit as when I approach along the other parts of the curve, along root of x. And again, this happens to be 1. Now finally, I verify that f of 1 is root of 1, which is 1. So the limits agree with the value of the function at 1. Therefore, the curve is continuous. We can actually draw this curve. Not that this is very necessary. So what does it look like? So if I have x smaller than 1, here is 1. We have this parabola. What happens after 1? We have this square root. The square root function would have been something like this. So really, we are not using this red curve. We are using this white part. So this is the shape of the curve. And here is the sudden change of formulas at 1. All right, let's look at another example. So the other example is, let's say we have a piecewise function and we want to force it to be continuous. So we have f of x equal to c x squared plus 2x if x is smaller than 2. And it's equal to x cubed minus cx if x is bigger than or equal to 2. For what values of c is this function continuous? All right, let's see what happens here. So again, the top function is a polynomial. So without this jump at around x equal to 2, this would be a polynomial, will be continuous. this is another polynomial, will also be continuous. So the only possibility for discontinuity is when you jump from below 2 to after 2. So let's see what must be the case for this to be continuous. So if I push limit as x goes to c from the left, if I push along this curve from the left of f of x, not to c, but really to, my apologies, to 2, I should be approaching the same position as when x goes to 2 from the right. That must hold if the two pieces, the two wires, merge in the same location. So that means that limit as x goes to 2 from the left of cx squared plus 2x must equal to limit as x goes to 2 from the right along this formula. What do we get? This at minus 2 will be c 2 squared plus 2 times 2 must equal to 2 cubed minus c times 2. So the result is that if I move this around, the result would be that 6c is equal to 8 minus 4, which is also 6. And therefore that c must equal 1. Just solve this linear equation. The next question is slightly more difficult. So consider question number 3, where the function given is as follows. So the function is x squared minus 4 over x minus 2 if x is smaller than 2. It is a x squared minus bx plus 3 if x is bigger than or equal to 2 but less than 3. And it is 2x minus a plus b if x is bigger than or equal to 3. So we need to choose a and b so that this function is continuous. So that the function is continuous. All right, so what do we do here? So we know that the limit, the discontinuities are only possible where x is equal to 2, because this is a rational function that at 2 is discontinuous. And of course, when you jump over 3, there is a possibility. But each piece in its domain is a continuous piece. This is a rational function, continuous for all values that are not 2. This is a polynomial, continuous everywhere. And the last equation is a linear polynomial, also continuous everywhere. So how do we make it work? So first, we must have continuity at 2. So that means that limit as x goes to 2 from the left of f of x must equal to limit as x goes to 2 from the right. So this condition makes us get limit as x goes to 2 from the left of x to the 4, x to the second power, sorry, minus 4 over x minus 2 this is simply limit as x goes to 2 from the left of x plus 2, which is 4. And this 4 must be the limit as x goes to 2 from the right. Now if you approach 2 from the right, you approach along this polynomial, the middle polynomial. So that would be limit as x goes to the right, a x squared minus bx plus 3, which is simply 4a minus 2b plus 3. So we must have this equality. That must be equal. Next, we must have another equality at 3. So we must have limit as x goes to 3 from the left of f of x equal to limit as x goes to 3 from the right of f of x. So that implies that at minus 3, as I approach 3 from the left, I would get a times 9, because this is plugged into the middle polynomial, minus 3b plus 3 must equal to this limit from the right. That would be equal to 6, 2 times 3, 6, minus a plus b. So rearranging, what we have is then that 10a minus 4b should be equal to 6 minus 3, or to 3. We have this equation, and then we have the previous equation we just obtained, is that 4a minus 2b plus 3 must equal to 4. So this is our system of equations. We then have 10a minus 4b equal to 3, and 4a minus 2b equal to 1. So what we can do is we can solve, for example, for b. We can multiply this times, well, we can solve for a, so we'll multiply this times minus 2. And then we obtain another system of equations, which is 10a minus 4b equal to 3, and minus 8a plus 4b equal to minus 2. Now when we add it up, we just get 2a is equal to 3 minus 2, which is 1. So a seems to be 1/2. Now once we know a, it's very easy to obtain b. Simply plug 1/2 into one of the equations, and then we have, let's say, 10 times 1/2 minus 4 times b equal to 3. So what we have is that, rearranging this equation, we have that 5, move this 3 across, so 5 minus 3 is equal to 4b. 5 minus 3 is 2, so we have 2 equal to 4b. Finally, we have 1/2 equal to b. So that tells us that the value of a here in in this piecewise function has to be 1/2, and the value of b seems to be also 1/2.